Okay, Ron, go ahead.
Hey, folks, we've done 16 of these already, starting back in early March as we eased our way out of the pandemic. Ladies and gentlemen, welcome to the big SBAU Astro Hour. SBAU stands for Santa Barbara Astronomical Unit, your incredible longtime telescope and astronomy club for the South Coast here, mostly Santa Barbara. And our weekly podcast emanates from our homes, among us, Santa Barbara Astronomical Unit. I'm Baron Ron Heron, your host, live from the homes of different folks on Zoom. I don't think we're live on YouTube at the moment, but it'll be replayed. And I got to tell you, the Santa Barbara Astro Hour has done 16. This is episode 17, series 2021. As we get rid of our masks for the next hour, we're going to talk about a lot of stuff going on, space stuff and astrophysics. And I want you to meet the Brain Trust right now, starting with our beloved president, 3 series. Actually, one of them we got elected, and I guess we got through the second year, the 2nd December. They revoted us in, Jerry, but the third one we were at home, and so we just sort of laid over.
My records here show that I was president since 2017.
Oh, okay. And I came in on your 2nd year, I guess.
Yeah.
And we all miss getting together on those first Fridays. Sooner or later, maybe we'll be back at the Museum of Natural History. Let's meet the man up in the upper left who is out of town, but still on board. Tom Totten, our webmaster. Good morning. On Monday, the 21st, and the first day of summer or second day? Was it yesterday, solstice?
It was 8:20 last night, something like that.
Okay, that's Chuck McPartland, our incredible outreach coordinator. I'm going to call this an outreach real quick. Tomorrow night, 6 to 8 online. You can spar with the Goleta City Fathers about those new LED streetlights they're putting in out there.
Yep.
We'll talk about
They don't
that.
listen to us.
We're the only ones that are against it all. It's saving
No,
money.
there's activity all over.
Is there?
HOA is against it also.
Well, I'm willing to kick it around myself. Chuck, congratulations on making it. Give our love to your wife, Pat. Same for you, Jerry. Your wife, Pat Forgy. Tom's wife, Suzanne, I guess is still here. Let's meet Bruce Murdoch. He's on the mid-right there. Also president of the Santa Barbara Theater
Organ Society, SPTOS.
All right, we'll get a shot from
Barbara
you.
Theater Organ Society.
And you're really upset about not being able to focus at night with this June gloom, but we'll talk about it.
Yeah.
Bottom right, joining us, and we have yet to talk to him. There he is, the former, I got to tell you, one of the great science instructors at Westmont College, Tom Whittemore, who edits our newsletter. How are you, Tom?
Morning. Fine. Thanks, Ron.
Let me give you some headlines. These are the things we're going to be talking about this hour. China is now in space with, what did you call them, Chuck? Taikonauts?
Taikonauts.
That's
How do you spell that?
Taikonauts.
Oh, okay.
You suppose Tycho means astronomical or astro in Chinese?
Or heavenly or something like that. Yeah.
Okay.
Yeah.
So they're orbiting in their own space station, a little smaller than ours, launched from the Gobi Desert last Thursday. We may or may not, looks like we probably did have a supernova to watch over in a distant spiral galaxy called Virgo. Might be able to talk about that. Summer solstice, we'll get into that. 2021, 14 hours, nearly 54 minutes of sunlight in one day. The Webb, as we told you before, Webb telescope has been delayed in its launch from the end of October again, possibly mid-November. Oh, and the sunspot cycle. This is something I heard about several weeks ago. I guess it just officially kicked off. You want to kick off and talk about that, President Jerry, for a few minutes? The sunspots, 11 years.
Yeah, I think pretty much everybody knows there's an 11-year sunspot cycle where the number of sunspots you can see on the disk goes from a minimum, frequently 0, to a maximum, and I don't recall the maximum number that it typically gets to. But we just passed the minimum, and we're starting up into the next, what is the 25th observed cycle for the sunspots. Tom, could you show the picture that's associated with that? Yeah, that's the graphic. Down below at the bottom, it shows the sunspot cycles from the 1800s. Then, and the big graph up above with the 25 in it because of the 25th cycle that's being measured. The starts out in 2020 when we went through a minimum. About early in 2021, we had a spike of a lot of sunspots, and now we're relaxed back down to the smooth curve. The red curve is just a bell-shaped curve fitted to the average numbers that are expected for this cycle. Now,
and there are actually two predictions for the activity in this next cycle. One predicts very high activity, and one predicts activity as shown here, kind of normal.
yeah, typical of predictions. We'll have to wait and see. The next picture shows a picture of the sun and what we have right now on the 19th.
Let me get there. Hold on.
Okay.
Trying to get there. Getting the wrong way here.
Black spots that heavy up on the surface of the sun. It's all electrical. There you go.
This is a picture of the sun taken on the 19th of June, and there's one sunspot cycle, or one sunspot in the middle of the disk at the top,
Right.
2833, and way over on the right, 2834, that's a flare, a bright spot. Now,
Well,
what
that's
happens,
a plage. That's a plage. That's actually where another sunspot may appear.
oh, okay. Okay. So the sunspots, the sun is a plasma, which is a ball of light gas, but moving charges, which is the plasma is protons and electrons all milling about, but not in atoms. And so they're charged. And whenever you have a moving charge, it produces a magnetic field. And so the sun is full of moving charges. And so it produces this complex arrangement of magnetic fields. And since the sun is also a plasma or almost a gas, it doesn't move, it doesn't rotate at the same rate. So the different regions of the sun move at different speeds, and you get different macular or large scale magnetic fields. And as the sun rotates at different rates, these magnetic fields get twisted up and crossed over each other and everything, and wear them. And so they get very complex, like winding up a rubber band past where it likes to wind, and it starts getting knots and all sorts of things. So magnetic fields are continuous. They don't have a start or an end. And so when they go through the surface of the sun, they loop out of the surface, they loop into the surface later on in the sunspot cycle when it gets more active. And when they go through the surface, they line up the spins of the particles at the surface of the sun. Now, heat is defined as random motion of things. And when you get everything lining up, that's no longer a high temperature. That has order to it. And so the region where the sunspot or where the magnetic fields go through the surface, that cools off because the particle spins are lining up. And so that region then appears darker than the surrounding sun because it's slightly cooler because of this alignment effect. So as it gets more complex, you get more sunspots, more twisty magnetic fields coming out until finally it passes a critical point, and then it starts unwinding again. And the magnetic fields become simpler and less twisted up. And then the sun goes back to being something that shows very few sunspots.
22-year cycle. What science doesn't know why?
Well, it's described as both an 11-year cycle and a 22-year cycle.
Yeah.
The 11-year cycle is the apparent increase and decrease in the number of sunspots, but they change polarity every 11 years. So the real cycle is 22 years.
Would it be possible to compare those spots where I assume the lines of force are coming out to, if we could see it on Earth, a smaller version, but we can't see it, that would be the magnetic North Pole or South Pole, wouldn't it? Similar.
It doesn't have a simple magnetic North Pole or South Pole. It's got a lot of poles.
Oh,
but yes, the magnetic field lines, one of the things they do to reconnect and simplify is to reverse. So
okay.
we can see it. There are plots of, there are pictures of the sun with plots of the magnetic fields that are measured in them, and it's quite complex in many cases.
But you're right, Ron, that particular area where the sunspot is would appear like our North or South Pole, where you have an ordered series of lines coming out or entering.
Right.
And is that the source of the radioactive showers we sometimes get? that are thrown off?
Sometimes the magnetic field lines will suddenly, as they're adjusting themselves, sometimes they'll jump up outside of the surface of the sun, and then you can see them. That would be a loop prominence over on the right there. You can see there's some loops, and those things are magnetic field lines that are actually, you can see them because they're highlighted by the material that's cooling off. Again, once it goes through the atmosphere cools, and the magnetic field lines may be going out from the sun, but the material in the sun's atmosphere is actually falling down toward the surface. Because the magnetic field line is there, it's actually cooling the surface of the atmosphere of the sun.
But Ron, you can also get, when the magnetic lines reconnect suddenly, you can get a release of energy that's like an explosion.
Yes.
That accelerates particles towards us, and we get what's called a coronal mass ejection.
Right.
So I think that's what you were thinking.
Do any of you gentlemen have a device, a filter that enables you to see them on your amateur telescopes?
Oh, yeah.
Not to see the magnetic field lines, but the sun is mostly hydrogen, so all the activity you're going to see is in hydrogen mostly. And several of us have telescopes that look only at the hydrogen line, hydrogen alpha.
Okay, I got a question. If, not if, plasma is a soup of disconnected protons and electrons, in other words, the constituents of hydrogen, and protons have the opposite charge to electrons. So if they're moving, there's no net charge moving. You got plus and minus particles moving.
Right.
So how do we end up with a magnetic field out of that?
There's that gets into plasma physics, but there are regions that move together. Not every ion is independent of every other ion. A moving charge produces a magnetic field, but in turn there's feedback. The magnetic field also constrains the motion of the particles. The field is called magnetohydrodynamics.
Oh, yeah, yeah.
Well, those black spots on the sun are mostly bigger than the
Good
Earth.
question. What's that?
The big black spots that are now going to start filling the sun for the next 11 years, many of them are bigger than the Earth is, probably multiple Earths, right? Why are they dark? Why do we not see any of this plasma that Bruce was talking about?
Because they cool the surface down, Ron.
They are cooler. So Ron, roughly the temperature of the sunspot area is about 4,500 degrees, whereas the surface of the sun is about 5,800. So they're still very hot. They're still extremely hot. Okay?
Yeah, if you had a sunspot all by itself in the sky, it'd be brighter than the full moon.
Yes, correct. Brighter than the full moon, Chuck, right? Yeah.
So it's still mostly hydrogen burning, and yet we're a third generation star. I thought the first generation.
It's not burning, Ron. It's just out there, and it's ionized.
Yeah.
Right.
What do you mean out there? It's on the surface of the sun?
Yeah.
It's hot, but it's not fusing. The fusion is.
Yeah, Ron. I mean, what you see with your eyes is basically last couple of 100 kilometers of the sun surface. Okay, right. And it's quite hot. Okay, but don't forget there's this nuclear fusion going on deep down inside the sun, where the temperatures might be 13 million kelvins. Okay, but you're just seeing the last stuff on the surface, if you like.
In other words, all the higher elements, because they're all there inside the sun.
Oh, they're there. Yeah. I mean, when we studied the sun at Lockheed, we were looking at, I think, something like 16 times ionized iron. So there was iron. We were looking particularly in the corona, so we weren't really looking at the photosphere. We were interested in what drives the corona to these incredible 1 million, 2 million Kelvin temperatures. Okay, and so we are looking way out in the extreme ultraviolet. Actually, we called it soft X-ray. 171 angstroms was where we tuned our telescopes.
But Ron, those other elements are tiny constituents of the sun.
Right.
You can think of the sun as essentially a ball of hydrogen.
Thank you, Chuck. Yeah, that's correct. Yeah.
But we got part of that refuse that was left from the last explosion in the generation 2. There's been about 3 generations, right? And it keeps reusing the stuff that's made in the earlier stars. We're 3rd generation, and our planet which congealed as a solid rock, has got everything, all the different elements clear up into the 90s, right? Isn't all that also in the sun?
Yes, but in
Yes.
very, very small concentrations relative
Right.
to the rest of the hydrogen that's there.
You know,
Really?
even though many of us have a hydrogen alpha telescope, you can get other telescopes that look at, I forget the names, like calcium, which is a
Right.
green line, but the sun is very faint in calcium, hot calcium. There's not nearly as much of it. The major activity, the easy stuff, is all in hydrogen. That's
Yeah.
where it's happening.
Yeah.
And where is the hydrogen? Everywhere, or just on the
Yep.
surface, or down in
Yep.
the middle?
Yes,
Everywhere.
It's everywhere. And it's becoming helium.
Yeah.
And
Only
some
in
of
the
the heat,
core, Ron, only in the core.
Only in
only in
core.
only in
And-
the core, the fusion.
And the primary thing that bombards things on the moon, for example, or on Mars, are protons from the sun.
Yeah,
I
from
imagine-
CME, right?
Yeah. Well, they're listed also as the solar wind, but you get a big massive clump of them as a CME.
So,
Huh.
so just a quick one here. So if you actually look at the spectral analysis of the surface of the sun, you'll see these dark lines, dark lines, dark lines. Basically, they are lines of the elements that are present on the surface of the sun, and there's a lot of them. There's a lot of them. But like Chuck said, these are way, way, way down in terms of numbers as compared to hydrogen. Way down.
Really?
Mhm.
Even though
I don't know if
hydrogen-
Tom can pull. I don't know if Tom could quickly pull up a spectrum of the sun, okay, through all of the elements. But you'll see a lot of dark lines, with all these elements, but way, 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 way down in population. Okay.
And there'll be two prominent dark lines in the yellow, and that's the calcium that people look at with a calcium scope.
But back in the first
There you
generation.
go. Thank you, Tom. Good job.
Beautiful. Looks like a gay pride parade.
Now, if you look up in the big square spectrum that goes from blue to red at the top, if you look up toward the top there, it's there's a big dark spot, a very wide dark spot right there. Tom's pointing to it. That's the hydrogen in the atmosphere of the sun. The sun itself, the surface, emits all these colors, but no lines. And then these lines are atoms that are in the atmosphere of the sun, and they take their own specific wavelength out of the emission of the sun. And so that's the hydrogen alpha line up there. And it's the darkest because there's most of it. And it's pulling out. Now, these have to be atoms. These are combined. These are no longer protons and electrons. These are atoms in this atmosphere of the sun and above the surface.
You've also got some big wide bands in the green, right in the middle of the green, and some down in the blue. Those are also hydrogen.
I don't know. I tracked down the hydrogen alpha. Hydrogen has a whole series of things that are in certain patterns, the Lyman series and the Balmer series.
See
Oh,
what
yeah.
I didn't
Tom just
check
brought it
those,
up.
but they're all over.
See what Tom just brought up.
Yeah.
Mhm.
Now, do all the elements give a different marker, a different line?
Different set of lines.
Yeah.
Set of
Yes,
lines.
different lines, right.
Would everything be on the periodic table be represented? There's your calcium, here's your iron, here's your gold.
Yes, it is. And as a matter of fact, one element was discovered because they were lines in the solar spectrum that nobody knew what it was. Can you guess?
It was
what that
called
was?
helium.
Helium.
And I was
Yeah.
wrong. I was describing sodium lines and calling them calcium
Right,
lines.
right, Chuck. Yeah, the sodium D lines.
Yeah.
Yes.
The doublet.
I was just going to mention to Ron that, this beautiful colored background that you see is a representative of what they call a continuous spectrum. So like you have a light bulb and it just gives you a splash, okay, of the spectrum. These dark lines are absorption lines due to the different elements in the sun's atmosphere.
Tom, could you go back to the XKCD one?
Oh, you want to go that one? Okay, hold on.
Yeah.
It's right there.
Now, XKCD, this is a set of scientific jokes. And this is a joke spectrum.
A joke?
Only in the sense that you see the spectral lines for these giant sunglasses are down there.
Where? Is he pointing to it?
Those giant sunglasses.
Oh, yeah.
Yeah,
Okay.
so they just added that label as a joke. So if you want to go to XKCD, they have sometimes very clever, sometimes very esoteric scientific jokes.
And in general, when you're seeing dark lines, it tells you it's something cool. And when you're seeing bright lines, it tells you it's something hot.
Yeah.
Right. Correct.
But now science is seeing these lines in distant stars, aren't they? They know what other stars
They
and
are.
even some.
Oh, yes. Oh, yeah.
As a matter of fact, back in, I think, the 1700s, some famous astronomer said that we will never know what the stars are like because the only thing we get from them is their starlight.
Yeah. So that, by the way, was a writer, a philosopher named Lecomte.
Okay.
And right after he said something like that, spectroscopy was invented.
It just exploded, yeah.
Yeah.
I'm imagining astronomers and astrophysicists are determining that all stars have their own 11-year cycle or 20-year cycle or 40-year cycle. They all have solar spots or sunspots of their own, I would imagine. But there's no way to see them, right?
No, they don't all have sunspots, but cooler stars tend to have more because there's more convection and stuff going on in their atmosphere.
Okay.
Right.
They all have magnetic fields. What the consequence of that is unique to each type of star and situation.
Yeah.
We'll get to another star later in the talk today, Wolf Riot stars.
I was going to bring that up. Yeah.
Yeah.
Well, is that part of your night sky, Jerry? You want to go?
Yeah, somewhere it's down toward the bottom, I think. Oh no, it's one of the star clusters that's got 3 or 4 Wolf Riot stars in it. MGC 62 something or other.
I also
By the way, the big broad band in the green is magnesium.
Yeah, could be.
Oh,
Okay.
I'm looking at that spectrum. Yeah.
Ron, maybe we should go a little bit in order on Jerry's topics there. That'll make it easier to track things through.
Well, let's I mentioned the headlines at the start of the show. The China launch. Anybody know anything? Want to comment on that at all?
You just covered it.
Where did they launch from?
Where
What?
They launched from Gobi Desert, like you said.
Gobi?
Oh.
Not from their own Canaveral on the eastern coast. You want to talk about a supernova in Virgo in a distant spiral galaxy?
Not much to say.
Okay, so they took a picture of it. Can we call that up?
That was a Facebook friend of mine in France, Robert Kaziliak, I think his name is. And
Okay,
he took a picture of this supernova in NGC 5427.
there it is.
And I passed this around because it's a nice photo of a supernova, but there are tens of thousands of these things every year. And if you look through a listing of it, it's not highlighted in any way anywhere except from me because Robert took a picture of it. And so I passed it around.
Well,
There's his name, Robert Kaziliak down in the lower left.
Yeah. Notice how it outshines all of the whole galaxy.
Yeah.
well, it's about as bright as the center of the galaxy, but that's not an added white dot. That's actually it exploding where the
Yes,
two lines.
that's the star.
Yeah.
It becomes
Okay.
very, very bright.
Before in the upper right that Tom is highlighting, and then the after is the main image.
Mhm.
Have we ever seen one go off in our galaxy?
Yes,
We have.
1987.
87, and they got pictures of it and everything that
Well,
didn't affect.
that was in the Large Magellanic Cloud. That wasn't really our
Okay.
galaxy.
Right.
The last one that would see naked eye in our galaxy was 1604, Kepler's supernova.
Wow.
But there has been one. There have been a couple since then, at least, but they haven't been naked eye visible. They've been obscured by gas and dust.
Okay. Gentlemen,
I was just
We're
going to
not-
mention a handful of years ago, we looked at one, I think it was an M101. Does that sound right, Chuck? Maybe about 6-7 years ago.
There was M81 and also
M82.
M81. Yeah.
Okay, 81.
Messier 81.
Now there was a
81 or
supernova.
82.
It was
There
in the
was-
cigar, M81, I think.
Okay.
Whichever
we
one
were-
the cigar is. I get those two mixed up.
But the only
About
way we're
15 years ago, there was a supernova in M51. And I was out testing a tracker of mine and I imaged the galaxy and the supernova. But I was just testing the equipment, so I wasn't really paying attention to the content of the image. And a couple months later, I saw that that was in there and I had a picture of it that was close to the discovery date. So
Pretty good.
I always look at my pictures now right after I take them.
That's pretty good.
Well, based on that one we just saw in Virgo, if we had one in our galaxy, the Milky Way, let's say not far from us in our arm, would there be no night? Would it obliterate the sky pretty much?
No, but it would be maybe visible in daytime, and it might
Yeah.
cast shadows at night.
Yeah.
Okay, and it wouldn't hurt us any. And I mean, if we're seeing it, it's a speed of light, and so but the solid stuff that would hurt us would take a lot longer to get here than the light did.
Yeah.
Wouldn't it?
They're only dangerous if they're within something like what, 35, 40 light years.
Yeah.
It's
If it was your
considered
star
like,
that went supernova, you'd be in
Line.
trouble.
So Betelgeuse hasn't done it yet, and it's what, 600 light years out there? Let
No,
me
it
do an
hasn't done it
announcement. Let me do a quick announcement here. I'll call attention to this. Well, I'm going to call this an outreach because it comes from Chuck McPartland's email. In Goleta tomorrow night, a town hall virtual meeting, everybody. You're advised or recommended, invited, 6 to 8 p.m. City will soon replace 1,300 of their high-pressure sodium street lights, HPS, throughout Goleta with new energy-efficient LED street lights. They save money, they say, require less maintenance, provide clearer lighting, but give us headaches with our night skies. So meet online. I guess it's meet.google.com/NQX and a bunch of other stuff, or get Chuck's email address. Are you, any of you going on and taking them on tomorrow, 6 to 8?
I think
I
that's
might.
a telescope workshop.
Yeah.
Oh, that's right. It is workshop time. Is that still going?
Yes.
Of course it's
Oh, yeah.
going.
yeah. Tim Crawford, by the way, says he can't make it tomorrow because they're having a planned power outage.
Is that true, or are you being funny? Because
No, that's true. And
Oh, it
also,
is?
if you go to the City of Goleta webpage, you can get the link to this meeting.
okay. So these lights, you can buy bulbs for your own house that are LEDs that are really low wattage but high output, right?
Yes.
Yeah,
We have,
they're,
most of our bulbs here are LED now.
But we don't like them.
the
Do they?
typical tungsten bulb is about 3% efficient in converting electricity into visible light, whereas the LED ones are getting up toward, I don't know, 50% efficient.
Well, other than the astronomy clubs like our own, might people not be able to sleep? They're going to have to pull their shades. Are they that bright? Even though they may be aimed down, I assume
Well,
they
in
have.
California, their streetlights are not allowed to shine in people's windows.
But they do, and I've got a work order on in the queue at Edison because the streetlights that they put into my street, the telephone poles are warped toward the ocean. So the LED, the light fixture tilts up and it illuminates the second story of my house. And it doesn't put any light on the south side of the street. And I suggested to them, well, why don't you just come put longer bolts and some washers and, tilt the fixture back down where it should be. Oh, no, we can't do that. They've got to go put a shade on the light.
Wow.
It's
they
called
put
light
shade-
trespass, and I had a 6 or 7 month battle with Southern California Edison to get a new, better shielded light on my street. Although in my case, it was a high pressure sodium light that was giving me trespass. And they actually came and replaced it with an LED that was shielded pretty well. And I had that for a couple of maybe 6 or 7 months. And then they came and replaced it with yet another LED that is now very poorly shaded. And I have light trespass again.
What are they doing in Ojai to correct that? Because their astronomy club over there made a deal with them, and it's relatively.
Well,
dark.
they have a city ordinance that says what temperatures LEDs they can use. And so
Is
does
that
Santa
right?
Barbara County. But you can still put in much higher wattage on it, so that it's brighter, even though it's the lower temperature.
There's a very bad misconception that brighter is safer, and that's not correct. Uniform is safer. It doesn't have to be necessarily bright. You don't want dark spots. You don't want to have places that, that people can hide.
Well, if these LEDs are so darn efficient and bright, why don't they just tune them down and we even pay less money, I would think. But
Yeah, but because there's this misconception. In
Oh.
some
Along
places,
Del Playa Drive, where I live, past Camino Corto going east, They put 2 of them per phone pole now, and each one is 130 watts. I mean, you talk about daylight bright. That portion of that street is daylight bright, except the phone poles are too far apart. So you get great big bright spots and you have dark spots, and bright spots and dark spots. It
In
doesn't
some
work.
municipalities, they actually tone down the lights after a certain time of night, like 2 a.m., or they turn them entirely off. And that not only saves money, but tuning them down makes for a better sky experience too.
When you drive out of Westmont, you know, when we used to have our star parties there, the street lights are off, but as you come along, they have sensors and they turn on. So they only turn on where you are and they're off every place else. That's a good idea.
Well, they turn on by sensors or timers. They're not.
No, they turn on by sensors, either heat sensors or they're detecting your headlights, but I don't know whatever the sensor is, the stationary illumination on the curving road that you drive to get out of Westmont, the
Right.
lights are off until you come upon them, and then all of a sudden they turn on. Not everyone, just the one that's near where you are.
Okay.
Thomas brought up the Ojai ordinance there at the top of this page. They have a dark sky ordinance protecting their sky.
Yeah, we had those guys over talking to us several years ago on a
Yes.
first Friday meeting. And they resurrected their long dormant observatory and got a full-fledged functioning club going over there. Probably not now. Less throwing away our masks, we get to meet somehow, but I guess we're gonna have a very busy museum to contend with. Everybody wants our room, right, Chuck?
Well, I think what happened is the museum is focusing on trying to get revenue now because they lost so much during the pandemic. And our attendance, even if it's just to a meeting or to the star party, it counts toward their conditional use permit limit on the number of people that can come to the museum in a year. And so I think we're probably not going to meet again until maybe next year or very late this year.
Wow. Because by then they will have recouped enough of their losses.
We'll
We are
see.
one of the few clubs that are endorsed and supported by them. Is there also a photographic club? Photography? Believe
There's
it
a
or not.
photographic club and there's an Audubon club, but I think we're the one that really gets the largest amount of support from the museum.
Yeah.
Yeah.
But we lost
Club.
Javier, our connection, didn't we?
There's a camera club that meets there also.
Okay.
Yeah.
Can I read you a couple of things from Jerry Wilson's talking points and see if they may mean something here? NGC 6231, also known as Caldwell 76, marked by a red bullseye, is an open cluster in the south sky. And let's see here, Zeta Scorpii, is that, or Scorpii? So part of a swath of young bluish stars known as Scorpius OB1. I can't read my own writing. I crammed so much stuff in here. What was that all about, Jerry?
That's an asterism called the false comet.
Well, that's the
In the
false
very-
comet. Okay.
So it's the star chart that Tom has up shows the Scorpius down there, and down at the bottom where his tail curves up to the stinger, but inside that red circle, the red bullseye that I put on the star chart there, that's where that cluster is, and that's the head of the false comet. You don't show the false comet on this star chart, but it's something that you can see visually if you have a very clear and dark southern horizon, because it is, for us, it is here at 34 degrees north latitude. It's quite close to the horizon, but it's very dramatic. It looks like a comet with the head facing down and the tail going up. And it's all made out of, and you can only see it with your naked eye. It's made up of a set of open clusters. And if you turn the telescope or binoculars on it, then you see the individual stars of the cluster, and the effect of a false comet goes away. This is also an extremely dense region, a target-rich region of the Milky Way, looking toward our galactic core. So you can see the clouds of the Milky Way there, and then you, all these little clusters of nebula are highlighted that are easy to see objects, mostly in the Messier type. For example, M8 and the Lagoon Nebula, that's its popular name. So it's a very good region to move around in with the scope.
Mhm.
Has it been reported by various astronomers through the ages as, hey, I spotted a comet? And then they
I
had
don't
to,
know about that. As an amateur, I just learned that there's something called the false comet. And when I have opportunities, which have largely been from up at the gun club on the top of West Camino Cielo, at times, like this time of year, it's very visible.
is it only
It's-
150 light years from Earth? Is that Zeta 2 or HR 6271? Do you know your telephone numbers in the sky? Well,
That's the head of the comet.
oh, okay. And that's a big nebula we're looking at? Or is that
It's
part
a,
of
it's a set of star clusters. You
Oh,
know,
star.
a lot of early in astronomy, faint fuzzies were seen. And then when they were looked at with telescopes, they were resolved into stars. And so people believed that everything eventually was just a cluster of stars. But it turns out some of them don't resolve into stars. Some of them are nebula.
And it goes without saying, our night sky would be a lot less bright or less dark if we were in a cluster. In fact, some of them, it'd be daytime 24 hours a day, wouldn't it, if we were part of those star clusters? Would you like,
Go ahead.
to do what?
Go ahead.
Night sky, hour after sunset. I assume it says Monday, so is that tonight's sunset? Bright red star Antares will be in Scorpius, visible above the southern horizon. It's a magnitude 1, and it's near star clusters. Is that what we're talking about here? Including M4, due west of Antares. And then 2 open clusters appear in Scorpius. I guess that's, you had a lot of this scattered over several parts of your talking points, Terry. So
Yeah,
I'm trying
the give up making, trying to make sense out of it. This is just a very rich part of the sky.
is it? Well,
Now, the
binoculars you can use.
Oh, yeah. Oh, yeah.
70
On Monday night, the one interesting thing is, it's all interesting, is that Mars is going to pass right through the Beehive cluster M44.
Ah,
So it's a great opportunity to take pictures if we can get away from this marine layer.
Yeah, it's also very low on the horizon.
Right, right.
and Jupiter's eastward progress will stop around 10 p.m. in Aquarius.
Which day are you reading from?
Monday, June 21st. Jupiter is
Monday,
eastward.
Okay.
And that, so are they close together, Mars and Jupiter?
Oh,
Not
no.
terribly.
Not terribly. But Jupiter goes into retrograde, reverses direction, right? Starting
Yeah.
tonight.
Mhm.
Tuesday, the 22nd, tomorrow, big ring in the summer. Oh, ring in the summer by the Great Globular Cluster, Hercules, officially cataloged as M13, Messier 13, ancient grouping high in the sky among the sons of Zeus. It was discovered by Halley himself, who did not discover a false comet. Telescopes, binoculars, even the naked eye. Oh, here's my note about Mars passing the Beehive.
Yeah,
Beehive is a cluster of stars, right? It's not a galaxy.
it's a big
It's a
cluster.
big cluster. It's naked eye visible. It's large.
Yeah.
Okay, does that make it an asterism?
No,
Beehive? It's not an asterism.
no.
That's
Really,
it.
but the ancient Greeks used it to predict the weather. If they could see it naked eye, they figured it wasn't going to rain the next day.
Okay.
It's also known as Precipice the Manger, you know,
They estimate how many stars are in it. They know.
hundreds.
About 3 million.
Okay.
I don't think
We're
anything.
talking M44, Bruce, not M13.
Oh, I'm sorry. Okay.
Venus will pass 5 degrees south of Pollux in Gemini about 8 o'clock in the morning. So we won't be able to see that, but be advised. I assume that's part of Tuesday. Going on to Wednesday of this week, the 23rd. Mercury, after being stationary on Tuesday night. Does anybody know what's happening with Mercury? Can we see it?
Not now. Yeah.
Not now.
It's very close to the sun. It dove into the horizon, so it's heading toward a morning time apparition.
That's right. That's right. Mhm.
But on Wednesday night, the moon will reach its closest point to us. That's the perigee, right? And 4:50 a.m. Let's see, dark sky, 5:55. I got all these numbers. Neptune's also up there. You can find it in the northeast Aquarian sky, Aquarius, with binoculars.
There you go, Tom. You just passed it.
Tom, you're awesome. You managed to call things up so fast. It's just amazing.
Looking for Neptune, right?
Yeah,
Okay.
But you got Jupiter and Saturn there too.
The thing about the planets is they're always going to be in a zodiac constellation, aren't they? Because they're on the ecliptic.
yes.
Well, yeah, not in, sometimes they're in constellations that aren't officially part of the zodiac, like Cetus, the sea monster, and Ophiuchus.
Oh, good old Ophiuchus. Car company should name a new model. The new 2021 Ophiuchus is out.
Actually, yeah, isn't it Pluto would be close to Saturn there somewhere?
It showed up on one of the
It's in
charts. but I didn't
Sagittarius, so it's
highlight
off to the far right of that image you're showing.
Oh, yeah, it's right there. Yeah.
it. Yeah, Pluto. Yeah, there it was.
Are
Good
you
luck.
saying you guys can see Pluto in your telescopes?
I've
It's
seen it. in
just,
61
it's very
inch.
dim. It's just,
Yeah.
looks like a dim star.
It takes a lot of effort. It's 14th magnitude now, and it's in a
Yeah.
bunch of other 14th magnitude stars.
Yeah, it's beyond 6-inch to 8-inch scopes. It's
Way
up
beyond.
around 11 or 12-inch scopes.
Yeah, I saw it in a 61 inch in Tucson some years ago.
But
That's
Pluto is not part of the Kuiper belt, is it? It's darn close. And it even intersects Neptune's orbit.
Yes,
Yes,
it doesn't intersect, but it passes inside of
it
Neptune.
comes inside, yeah. Mhm.
Yeah, if it intersected the planet, we'd really have a light show. Shall we do a full moon by Thursday, 2:40 a.m. Eastern time, near the lid of Sagittarius, teapot asterism. Difficult to see though. What is difficult to see? The bright moon. Oh, that's true. Sagittarius, you won't be able to see it as well because of the full moon, which Tom may or may not be calling up. Early in the morning, the great square of Pegasus will be in the eastern sky high, formed by Alpha. Let's see. Alpha Biz? No, that Alpha Diz. I can't read my own writing.
No.
Algenia.
Alpharats?
Alpharats.
Alpharats. There it is. And Mark, hell, I
You
can't.
skipped Alganib.
You're right. I did. I can't read it either. It's alphabets. No, what was the first one, gentlemen?
Alpharats.
Alpharats, Algenib.
Jaded.
Okay,
Mark-
and Narcab.
Markov?
Oh, it's an M. That's right. And then Shibe.
Shiat, I just say Shiat.
Shit, that's a T. Okay, those are the four.
And that star called Enif there is the nose of the horse. That means nose, literally, nose.
Is that
Somehow
right?
the last few minutes reminded me of Tim Conway, but go ahead.
And,
Well,
and you can see off the nose there, off Enif, there's M15. That's a globular cluster. And
Beauty.
from a dark sky, that is just barely naked eye visible. And there are Arabic stories about a fly near the nose of the horse.
Oh, that's neat. That's neat. Stuff.
Horsefly. Have you ever seen a horsefly? I grew up with those. They're a monster.
Does anybody know what the other star names mean in Arabic? They're like Alpharets and Algenib.
No.
Sounds
Well,
like-
Alvario, I think, means beak of the hen, does it not?
Yeah, but that's in Cygnus.
Cygnus.
I know, but you were just talking about words that start with al,
Oh,
you know,
Oh.
Arabic words.
Well, Al means the, yeah.
I know.
Right, it's an article. It's an article.
Oh, doesn't mean of.
No, like in Hebrew, it's L.
Means the.
Okay. All right, gentlemen, into Friday. Well, so what is that? Okay, here we go. Winged horse constellation. We got past that. We're talking about Enif, E-N-I-F. You can see with binoculars or a small scope. It's a faint companion star with it about what is the apostrophe? Is that called an arc?
2 minutes,
Minutes. Those are minutes. And how many minutes are in a degree?
60,
60.
Jeez.
just like in minutes in an hour.
Okay.
There's 60 seconds in a minute.
How in the world do you, that's just tiny as all get out there in space, I guess.
Well, that means a second is 1/3600th of a degree.
How many minutes are around us or in a full circle, you suppose? Thousands, I guess, right? 60 times 300.
Well, it's 60 times 360.
Okay, that would be quite a bit. Anyway, ENIF, which is fine, spelled backwards, ENIF. Tell me about that star. What?
It's
why did that-
21,600 minutes in a circle.
Is that right? And you can
Well,
actually,
60 times 360. Well, yeah.
and you can actually
Times
plot these
24.
things through your telescopes. Amazing. Well, it looks like we're talking about, it's not a companion star, or it's not a binary, right?
It only appears to be a binary.
Oh, so they're several light years apart.
Yes.
They're not orbiting each other. Companion star, northeast of ENIF. Does it have a name? The chance alignment, these two
If
stars.
it's not naked eye, it doesn't have a name probably.
Oh, okay. But we can see them together as one star with the naked eye. This is Friday. It wraps up our night sky.
Probably not detecting a companion naked eye at all.
Okay. And it's not far from cluster M15, about 100,000 stars out there, 33,600 light years away. What
And
is
that globular seems to have a black hole at its core. So it's an interesting globular.
there it is. Look at this. Now, what constellation is involved in this?
This is still
Pegasus.
Pegasus.
Oh, Pegasus, the winged, what part of the horse?
That's his nose. It means nose.
That's the nose we were talking about.
Yeah.
Yeah, this
Hey,
is the-
Chuck, would you like to fill in your comment about the horse? That you do.
Well, if you'll notice, Ron, looking at the horse, that he kind of ends at the waistline. He doesn't have any rear legs. That's because when he was put up into the sky, his rear half cracked off and fell back to earth and brought forth politicians.
Thanks, Chuck.
It's not like a minotaur, half goat and half something else, half horse.
Mm-mm.
He's actually shown in pictures as jumping out of the ocean because he's on the edge of what's called the watery sky. So you can see Pisces, the fishes down there below. You know, so there's that part of the sky that's kind of dim that was traditionally called the watery sky, and all the constellations have to do with oceans or water.
Right. And also, if I remember right, Pegasus, the flying horse, was born from the blood of the Medusa. Does that sound right, Chuck? Yeah.
Yeah, there's different stories on that one, but yeah, that's one of them. That the Medusa, when Perseus cut off the head of the Medusa, the blood went into the water and up sprang this winged horse that he then
Yeah.
used to ride around
Yep.
on.
Thank you.
Well, I'm assuming those are the same horses that are pictured in Fantasia, one beautiful segment. It's all done illustrated, animation, but God, they're flying in and out and settling down. They got little baby horses that are flying. That's all based on that medieval myth, aren't they?
All based on LSD.
And it's much older than medieval.
Yeah.
For our vast audience who are going to see a replay of this number 17 program, this is the Jerry Wilson cartoon of the week he sent us. Inside the observatory, a very happy, somewhat disgruntled, vindicating or vindictive mad scientist sitting there at the big telescope. Did you see this? Behind him stands his faithful secretary. Nearby lie two piles of singed clothing on the floor. The man's laughing hysterically while looking through the lens, and he goes, "Ha! Isn't that first the creep Foster on the floor, now that jerk Cummings instantly evaporated? I tell you, Miss Goodman, without a
Oh,
doubt,
yeah.
I'm looking at an authentic, genuine, full-fledged wishing star." Want to tell us the origin of that myth, if you will, Mr. Chuck? Who came up with wishing stars? Is that also Arabic?
I have no idea.
Yeah.
Pinocchio is based on that. Well, what shall we talk about? I got white dwarf stars in our menu. Color equals brightness. And if we plot brightness against color, we get a Hertzsprung-Russell diagram.
Hertzsprung-Russell.
Yeah.
Hertzsprung, what did I call it? Who knows? And I looked at it and I tried to understand it. So we're going to need your, if you can call any of that up, Tom. Where did Tom go?
Got it. Coming
Oh,
up.
there it is. Let me read what I got and then we'll take off here. Stars fall within a linear strip called the main sequence. However, there are some exceptions. such as, I guess, huge red giants like Betelgeuse, abnormally bright for red, and the white dwarfs abnormally faint despite their whiteness, which kind of confuses me. They're
Well,
degenerate.
white means very hot. And
Yes.
really hot things are usually just roaring bright. But these are so small that they're not very bright.
Okay, but they're not, are they what's left after a supernova explosion?
No.
No, they're what's left after a star like our sun goes through its planetary nebula stage.
Right.
Yeah.
Which, okay, I don't understand that. You mean,
All the hydrogen that was in the star to begin with has gone through its fusion stage and it has produced helium. And the star does not have enough mass to keep collapsing to generate more core heat in order to start fusing helium into anything else. So its end game is once the hydrogen fusion stops, that's it for the star. It's over, it's done.
Well,
So it's
they
just
can also go to carbon for white dwarfs.
okay. So but anyway, it's not generating, it's
Not fusing.
yeah, thanks. It's generating its heat from gravitational collapse, but it's not high enough. It's not massive enough to crunch down to start the next layer of fusion up. So it's just, that's it for the star. And what you see is residual heat as it's cooling off. And it's got a lot of heat.
okay, well, this is probably obvious, but I thought iron was the end. It was all over when you hit iron.
If you're a very massive star, iron is the end, and that's when you go supernova. But if you don't
Right.
have enough mass and enough oomph to go farther than carbon, then you become a white dwarf.
Okay, carbon is number 6 on the
Mhm.
scale? On
Yes.
the,
Yes.
periodic table?
Mhm.
Well, is that the scale we're talking about? Is that the diagram, the Hertzsprung Russell?
That's an elaborate version of the diagram. But yeah, the simplified version is the diagonal streak that goes right down from upper left to lower right, goes from blue to white, yellow, red. And those are normal stars that we see. The white dwarfs are this thing that does not lie on the mainstream. And the supergiants are other exceptions up above.
Are white dwarfs really, are they really considered still stars since they're not really fusing anymore?
Well, they are stars, they're leftover stars,
Mhm.
but they are not fusing. So
Just like a
I don't know.
neutron star is called that, but it's really just a leftover.
Yeah,
Well,
Maybe
Herschel
so.
Garnet is a red star, and you can see that quite easily.
Yeah.
Yeah.
You can see Betelgeuse and Antares and a whole bunch of
Well, I
Aldebaran.
mean, but Herschel's is a lot more red than his Betelgeuse.
Yeah. It's cooler.
Mhm.
Is that what that means? Red means cooler, but it's size we're looking at. That's why it's
Yeah.
so bright.
Well, it's a combination of size, mass, and color. You can see that in the white dwarf ellipse, the star Sirius B, which is the pup, the companion to Sirius, it's a
Mhm.
white dwarf.
Yeah.
And that's a true double star.
Or two binary.
Binary.
What is Fermi gas?
Where are you reading that?
Out of your notes, degenerate, let's see, white dwarfs abnormally faint despite the whiteness. They degenerate, maybe that's what you're talking about. They don't fuse, perhaps.
No, degenerate, the word degenerate, despite its colloquial meanings, it has a very specific meaning in physics, and it means two electrons that are trying to be forced into the same quantum state. Those are called degenerate electrons.
Quantum space.
So anyway,
Wow.
a white dwarf star is the surface of it is a set of degenerate electrons.
Well, I'm still trying to understand a star that's not fusing. How in the world do we get any heat or warmth, or what's happening? Is it oxidation?
Mass.
No,
something-
even in our sun, the fusion goes on in the middle, but the heat and the radiation has to work its way out toward the edge of the sun and then radiate off into space. Once the fusion stops in the core, the whole sun doesn't turn off all at once.
Right.
So it's still going to be many millions of years before all the heat that was fusing gets out to the surface and comes off.
Plus, you've got a bunch of added heat when it collapses from gravitational collapse.
Right.
Okay, so
It takes 100,000 years for the energy created in the middle of the sun to work its way to the surface.
I've heard that some of those light waves just bounce around like you wouldn't believe forever and ever.
Well, it's more that the photons get absorbed by atoms and then they get re-radiated.
Well,
So
I happened to learn recently from you guys that a proton and an electron together, crammed together, become a neutron. Is that true?
no. Oh,
Sort of.
proton, right?
Yeah.
Not a photon, a proton.
Well, a neutron is both, isn't it? Isn't it plus and
Sort of.
minus?
If
What?
neutron is an unstable particle, if you put it in free space with nothing else around it, with a half-life of 15 minutes, it will pop apart into a proton and an electron and a neutrino.
So
Okay.
Jerry,
Yeah.
Jerry, would you
Yes.
like to hear a hydrogen joke? I think we need a joke. Is that okay, Jerry?
Go ahead.
Okay, two hydrogen atoms are walking down the street,
Hmm.
and one of them just lost an electron. He goes, I think I just lost an electron. And the other one said, are you positive?
There's your
Gentlemen,
joke.
on that note, I'm gonna have to pull the plug on us. We've done an hour and we're gonna have to deal with the YouTube people to see why we couldn't hook up, pay our bill or whatever. But good luck with sky watching with the overcast and the full moon, and enjoy having your masks off. And we will do number 18 next Monday morning at 11 a.m., hopefully online. In the meantime, thank you very much for assembling with us for the SB Astro Hour, SBAU. We will live again, guys, inside the
All right.
Museum
Yeah.
of Natural
Thank
History.
you.
We also have a
Take care.
telescope
Thank-
workshop tomorrow night.
Yes.
That's right. That's 6:30 or
No,
7:30?
7:30.
7:30 to
7:30.
9. And
Or
Tim
Tim,
Crawford, sorry we couldn't put you on board. We'll see you
Okay.
next week.
I'll
Thank you,
post
everybody.
this on YouTube shortly.
Okay,
Thanks, guys.
guys.
Goodbye.
Bye.
All right.